Hello, all of you lovely pre-AP pre-calc students. This is Mr. Bear bringing you the video lesson, the first one of the semester, might I add, for skills 1 and 2, which will be about finding missing sides and angles in right triangles using trig. So it's called skills 1 and 2 because skill 1 is going to be about understanding the reciprocal ratios for trig functions, and then skill 2 will actually be about finding missing sides and angles. For this, I recommend that you have a scientific calculator by your side so that you can practice typing in things as I explain them. All right, so we're going to go ahead and get started. Let's start by recalling what we learned in our live lesson, the last class, which was the acronym for remembering the three basic trigonometric ratios. So that would actually be our first word. Ka is the second word. Tawa is our third word. What did this stand for? Well, it stood for the sine of an angle is equal to the opposite over the hypotenuse. So we took the sine, the opposite, the hypotenuse, SOH, so. Then we have cosine of an angle is equal to the adjacent divided by the hypotenuse, CAH, ka. And then the tangent of an angle is equal to the opposite over the adjacent. Tangent, opposite, adjacent, TOA. We're going to learn three more words today. They're just going to be the reciprocal ratios for the ones that we have here. We're going to talk about secant, which is abbreviated as SEC. Cosecant, which is going to be abbreviated as CSC. They probably did that so as not to confuse it with cosine. And then cotangent is abbreviated with COT. So I'm going to teach you which ones are the reciprocals of what, and we're going to do some practice here. All right, so first of all, when you look at this chart, I want you to think of this chart as two separate pieces, okay? The upper half, we're going to use a triangle. We're going to look at angle A. And what we're going to notice here is that sine and cosecant are reciprocals. Cosine and secant are reciprocals. And tangent and cotangent are reciprocals. Okay? Notice that the way that we say sine and cosecant, and then with cosine and secant, it's very easy for students to get confused, the ratios. Or the reciprocals anyway. They might accidentally think sine goes with secant or cosine goes with cosecant. That is wrong. Okay? It is sine goes with cosecant, cosine goes with secant. I'll explain as we go. Okay, so on this triangle, let's look at angle A here. We have our opposite side here, which would be BC. Our hypotenuse side is AB, and AC would be our adjacent side. It's the angle, or it's the side length next to the angle. Hypotenuse is always across from the right angle, so that is why we label the triangle as such. The sine of angle A is going to be segment BC, which is the opposite side, over AB, which is the hypotenuse side. So that means that the cosecant is going to be the reciprocal of that. So the cosecant is going to be AB over BC. So cosecant is just going to be the reciprocal of sine. When you know what sine is, just flip it upside down. The cosine of A, cosine we know is the adjacent side, so segment AC, divided by the hypotenuse, which is segment AB. The secant is the reciprocal of cosine, so we just flip that upside down. The secant of that angle would be AB over AC. Tangent is defined as being opposite over adjacent, so BC over AC. So the cotangent is just the reciprocal of that, AC over BC. All right, now I'm going to try these again as a way to review, but now we're going to use angle B as our reference angle. So it's very important that you know your reference angle because your opposite and your adjacent are dependent upon the reference angle. All right, now I do know that AB is my hypotenuse. It is directly across from the right angle, so that is why we label that. But now we know that AC becomes the opposite side because it's across from our reference angle, which makes BC our adjacent side. So now what we're going to do is we're going to find these same ratios, but this time we're going to be using angle B as our reference. So sine is opposite, so AC, over hypotenuse, which is AB. The cosecant is the reciprocal of sine, so we're going to just flip that upside down. Cosine, we know cosine, remember cosine is adjacent, so BC or CB, over the hypotenuse, which is AB. So that means the secant will be the reciprocal of that, so AB over CB. And for tangent, tangent is opposite over adjacent, so AC over BC. So that means the cotangent is just BC over AC. Okay, and so that is how we write these 6 trig ratios for a particular triangle. And now what we're going to do is talk about, and that was skill 1, by the way. So now we're going to go into skill 2, which is about how to solve right triangles. Okay, you know how to do some of this from geometry. Okay, this isn't really brand new. What might be brand new to you, well, it shouldn't be brand new to you. If it is, then you're probably doubling up in the courses. Anyway, to solve a right triangle, we are going to be finding all the missing sides and all the missing angles. Okay? With a triangle, we have 3 sides and 3 angles. So when we solve a right triangle, we will end up knowing information about all 3 angles and all 3 sides. In some cases, we'll have to use trigonometric ratios, which I call trig ratios, to solve each of them. I've given you some steps here what to do if you have an acute angle and a side that are known. Keep in mind that we're dealing with right triangles, so we automatically know the right angle will be in the triangle, so that one's kind of a given. But if you know an acute angle, which would be the non-right angle, and you know one of the sides, what you're going to do is you're going to first use your given acute angle as the reference angle. You're going to label your triangle with hypotenuse, opposite, and adjacent. You'll use the appropriate trig ratio to set up. You'll solve for the missing value. And to find the third side, you can use Pythagorean theorem or another trig ratio. If 2 sides are known, meaning that you only know the right angle and 2 of the sides, you're still going to label your triangle. That's always going to be the case. You're going to use the acute angle that you know both of the sides for that. And that'll make sense when we do problems. You'll use the appropriate trig ratio, and then you're going to use an inverse trig function to find the angle, and then you can find the rest of it using the steps we showed over to the left. You might also be able to use the Pythagorean theorem. All right, so let's try a couple examples. So on this triangle right here, we are going to find the missing angles and sides. We know it's going to be a right triangle, so I'm going to go ahead and draw the right triangle over here to the left. We know angle C will be the right angle, so I'm just going to call the other sides A and B. We're told that AC is 16 Sorry, that would be 11. Sorry, and CB is 16. Okay. All right, so when we look at this, since we don't know any of the angles, we know we have to find angle A. We have to find angle B. And we'll also have to find side length AB. So those are the three things we have to find. While looking here, I don't know anything about any of the angles other than a right angle, so I do know that I can label this triangle. So we have our hypotenuse. We have, I would need to choose an angle here. I know, I'll use angle A. I know the opposite side and the adjacent side. So what I'm going to do to find angle A is I'm going to start by using, let's see, what do I know about O and A? That's TOA. That means I have to use tangent. So I'd say tangent of A is equal to the opposite side, which is 16, over the adjacent side, which is 11. Okay? Now, in this particular case, I don't know what that angle is. So I have to do inverse tangent on both sides. So this is what that looks like. Tangent inverse cancels with tangent, so we just get A. And we have to use our calculators to do this. This is why I told you to get your calculators handy. We are going to assume to measure in degrees. So what we're going to do is we're going to make sure our calculator is in degree mode. On the calculator, the way that you will do this is, and it depends on your calculator, some calculators you hit second and then hit the tan button. And then for 16 over 11, you do 16 divided by 11, close your parentheses. And the calculator gives you 55.491. Okay, and again, we're measuring in degrees right now. If your calculator is not giving you that, then try doing 16 divided by 11 on a calculator first. And then whatever that decimal gives you, then hit second and then the tangent button. Or shift and the tangent button. And then you'll get this same thing. If you're not getting that angle either way, then you probably are in a different mode and you'll need to change your mode to degree mode. Okay? All right, let's look at the next one we can figure out. Let's see. Now that I know the angle A is 55.491, that makes it really easy to find angle B. I don't need to use any sort of trigonometry for this. We know that angle A plus angle B plus angle C has to add up to 180 degrees. We know that from geometry. The three angles in a triangle add up to 180. Well, angle A we just found as 55.491. Angle B is unknown. Angle C is 90 degrees. So if I just take 90 plus 55.491, I get 145.491. And if I subtract that from 180, I get that angle B is 34.509 degrees. And I know some of you could have calculated that much quicker than I did, but I just wanted to show you all the steps that are involved with that. All right, the last thing we have to do is find segment AB. To find segment AB, we are going to use, you can use Pythagorean theorem or you can use a trig ratio. I think for the purpose of this one, since I'm trying to teach you trigonometry right now, I'm going to use a trig function. Let's see, we want to know the side length AB. I know both of the other sides, so I'm going to just do cosine. cosine of angle A, which we now know is 55.491 degrees. That'll be equal to the adjacent side, which is 11, over the hypotenuse side, which is segment AB. I like to make this like a proportion and cross multiply. So AB multiplied by the cosine of 55.491 is equal to 11. So we divide both sides by the cosine of 55.491. And we get that AB is equal to, so I'm going to take 11 and divide it by cosine of 55.491. And we get 19.416. If you use the Pythagorean theorem, if you did 16 squared plus 11 squared equals c squared, these two add up to 377. When I square root that, you get 19.416. So that's just another way to show that you would get the same thing. Okay? All right, the next example, we have an angle and a side. So we're going to draw a right triangle. We know that angle C will be the right angle. Measure of angle A is 43 degrees. CB is 12.5. So now what we're going to do, we need to find the measure of angle B, and we need to find the value of AB and AC. All right, so looking at this one, if I label my triangle, we have our hypotenuse R. I'm going to use angle A again as my reference angle. So we have our opposite side and our adjacent side. Okay, looking at this right away, I can see that I will have to figure out one of these sides. I'm going to go ahead, well, actually, before I do that, let's find angle B. That'll be really easy. Angle B is just 180 minus 43 minus 90. This is the shorter way to do this, which is 47 degrees. Okay? So now we have angle B. To find side AB, so side AB is our hypotenuse side, I need to decide on a trig ratio. So I could use opposite over hypotenuse, okay? So in this case, that means I'm going to use sine. So sine of 43 degrees is equal to opposite, which is 12.5, divided by the hypotenuse, which is segment AB. Think of this like a proportion, so AB times the sine of 43 degrees equals 12.5 times 1. Divide both sides by sine of 43 degrees, and we get that AB is 18.328. All right. Now for the final one, to find AC, I could either use Pythagorean theorem, now that I know this side is 18.328, or I could use another trig ratio that involves the opposite and the adjacent. It's up to you what you decide to do. I think I'm going to do trig, so to find AC, I'm going to use angle A as my reference angle, so tangent of 43 degrees is equal to the opposite side, 12.5, divided by the adjacent side, which is AC. Cross multiply, so AC times the tangent of 43 degrees equals 12.5 times 1. Divide both sides by tangent of 43 degrees. And AC is 13.405. All right, and that is how we are going to solve a right triangle. We've now seen two examples of that, so we'll get to do some practice in class.